Hey guys, and welcome once again to my channel. And wait, sorry, let me just so hey, so yeah, it's just second question of the day. Just in Zoom, just getting some reps in. But I decided to just do like a pick at random. So sometimes when you don't know what question to pick, there's this random feature that you can just pick a question, and it kind of brought me to this question. So I decided to go ahead and like let's tackle it. So once again, it was new because I picked random. I don't want to pick something that I've already solved. What's the point? Because I always also want to learn. So that's why I sometimes log in my video because I want to like go through the learning process with you guys. So I'll talk about just get to it. So this is flood fill, easy one. I've been working on mediums all so far in all my videos. I said I'd pick an easy one. So I'm a bit tired. And no, sometimes when they're about Leetcode questions, it could be called easy, but we can all somehow, some of us can attest to the fact that some easy questions are not easy. Same way some medium questions are not medium. Could be easy or harder, depends. But let's take a look. I think it could be also subjective. So what's this question about? This is literally insane. An image represented by an m times n integer grid image, which is basically like a kind of 2D sort of. So technically, yeah, kind of like a 2D. Is represented by an m times n grid internet image where mij represents the pixel value of the image. You're also given three integers sr, sc, and new color. You should perform a flood fill. So when I hear about flood fill, the first thing is like I feel like it's that thing where it's like you hit at one side and it just fills out other parts. So yeah, perform a flood fill on the image starting from the pixel image RC. So from a certain designated start point, it fills out. To perform a flood fill, consider the starting pixel plus any pixels connected four directionally, starting from the pixel of the same color. So if the pixel color is, let's say, green, you look at its north, south, east, and west neighbor directly, and then see if they're also green as well. If they're also green, then that means that they also need to be filled. So replace that color with the pixels of new color. So replace the new color is blue, and then the starting point is green. That means if it's north is also green, it has to be blue. And they're saying that plus any pixels connected to those pixels. So literally, the first thing that comes to my head is traversal, but the first traversal that kind of hits my head straight is DFS. And let me know in the comments whether BFS came to you guys your mind first or it's DFS, but whether DFS or BFS, but eventually you might have to use one of those two. And I think DFS for me hits home first because even though both probably could be used, both should be able to be used in this scenario, I see DFS more, especially in the way of how any pixels just connected there. So that means if you can start from a point, you just keep going, and then from a certain direction, you just keep going, and then eventually you're gonna get everything filled. So I think that's what is hitting my mind, and I can give you guys some time to also think about other things, but for me, nothing hits home more than like a DFS approach. So this is just basically DFS. So basically, there are two ways to go about it. One could be a faster approach. So let's look at examples. So 111, it starts from this place. Oh, so this one is connected, this one is not zero, so it's not connected, but this guy also, its adjacent is connected, and this guy's adjacent is connected, this guy's adjacent is connected. So it makes sense that it would be this guy's, and if the new color is 2, then that means these guys here are all going to be 2. So I think there are two ways to go about it if you want to do DFS. One is you start from that color and you start changing it already, so 2 2 2 2 2, like keep changing it. But for me, one thing with DFS is if you change now, if let's say if I'm here started and I change it to 2 and then I change this to 2, how do I make sure that the connecting ones are also, now the connecting ones, I'll be checking if the value equals 1. So that could be a problem. So the only way it would work is if I probably change this guy here to 2 first, and then I make sure, so I initially first change this guy here to 2, or the new color they want us to change it to, and then, but you see, if you change it to the new color, if you go to any of these guys, they're not gonna be 2 yet, so that's a problem. So what you have to do is, if you decide to change it to a 2, that's a problem. So that's the that's gonna be a problem. See, I'm thinking over there to you guys, that's why it doesn't really come clear out, but I think you guys can see what I'm thinking about. If I just decide to change this guy to a 2 and okay, go here and see okay, then that means I have to keep in my head what the previous color was, or what the original, let's say, color was. So, or the original pixel. If the pixel was 1, then I have to change it also to a 2 as well, and then keep changing that way around. So I have to keep it that way. So that is the only way I can think of it right now, in that way. But why do I not feel comfortable about that? Because that makes sense. That really does make sense, but I don't sort of feel comfortable about that. That okay, I change to 2 and then I keep the previous color. If it was equal to the previous color, I change again. Okay, but the issue here, it really sounds problematic, but I guess I could see what could span out here, but we could try it and just see what goes on. So let's just try it and see. But the other way that I was also thinking was, as I go through it, I don't change anything yet. So I see 1, I have a hash map or a dictionary where I store like the coordinates, so the row and column coordinates of this in a dictionary. So I keep traversing, and if any of them is 1 or it follows that rule or that filling pattern, I just store all their coordinates in a dictionary. And then after I'm done, I just now loop through the dictionary, and then with all these coordinates, I apply the new color to them. So that was what I was thinking also. But it's okay. As I said, I think through this with you guys. There are 2 approaches right now in my head, and I wasn't feeling comfortable with the first one, but you know what? Let's take a step and let's do it. And if we do it and it doesn't work out, we can just how do I call it? We could just go ahead and just change it and then do the second approach. So let's just go ahead. This is gonna be probably a quick one, so it's an easy question. I'm not gonna keep in mind. So this is 0 0 0. Start from 0 0. The new color is 2. Clearly, if we start from that part, everywhere else it's just gonna be 2. Yep, pretty much makes sense. So we can try. Obviously, in a string or like sometimes in this kind of format, speed matters a bit, which is why I'm kind of thinking about going the first approach, or your interviewer could easily ask you how can you optimize. But let's just go ahead and code it up and see what's gonna go on. So as we said, we would have to keep the value of the original pixel, the pixel we're starting at, so we can just call it pixel, and then we can have that to be equal to image SR and then SC, and then we can have now we have this, we can just call the self.dfs. Probably we're gonna implement, and we're just gonna have the image, we're gonna have the SR, probably SC, we'll have new color, we're gonna have pixel. Sure, let's do that. Then we can return the image. So let's just keep this like out. So let's define DFS, because as I said, you can use BFS too, but I'm probably just going to use DFS for this one. We can have self, we can have image, probably should name it differently, but I don't really. SR, SC, new color, and then pixel. So with every kind of traversal like this word recursion, you need to have a base case. So for this base case, we just have to make sure that we're not exceeding any of the boundaries, or we have hit like a termination condition. That means that it's probably not equal to the pixel color or something, or the pixel value. So yeah, so it's just basically just defining them out. So let's say if the row is less than 0, or the column is less than 0, or the row is equal to image length of image, or SC is greater than or equal to image length of image 0. This kind of draw already. Image 0, and I think it could have been image, but I think here they said it was an m times n, which is why I'm taking a precaution, so, and it's better in an interview. So yeah, precaution wise. So image 0, So now we've done all the boundaries, sort of. So what else do we need to stop? Or image sr sc is not equal to, oh sorry, no, image sr sc is not equal to, what should it not be? If it's, as long as it's not equal to the pixel that we have, our original pixel that we had, if it's not equal to that pixel, what we do is we can just return, you know. So that just makes sense. So we return. So if, then we check if image or sc equals pixel image, yeah, image sr sc, we know we just set it equal to new color, and then we do the same on like the DFS. So we literally just call this function. So the DFS, we call the DFS on like image, we call it on like sr plus 1, yeah, right, sr plus 1 sc new color, then pixel. Then we're probably just gonna repeat these guys like 4 times on each of them, basically. So just gonna do that, do that, do that. So we just have to just keep sr minus 1 sc plus 1 for it to go on the same row, but it goes to the column right. So this one goes to the right, moves to the right, and this one, the next one, moves to the left. So you can guess it to be sc minus 1. This one goes down 1, this one goes up 1. So yeah, this should work, but we can run the code and see. Probably if we get more errors, we'll see, and if it's way too much, we'll go for the safe approach. So let's see. Yeah, probably an error. So if sr less than 0 or sc less than 0, or sr equals length of image, or sc equals length of image 0, or sr sc is not equal to pixel. Okay, so if it's not equal to pixel, we definitely want it to return, right? Because if it's not equal to pixel, we need it to return. Oh, sorry. So if it's not equal to pixel, we definitely need it to return. That's if it's, because if it's not equal to the pixel value we want, unless, okay, in all, let's just make sure we're always having the right pixel value. So print pixel, so we can just see what's going on at every point. See if a pixel is changing or not, because we don't want it to be changing. Because if it's not changing, that's good. Because if it is changing, then that could be a problem. Because I know Python, oh, it is still keeping it as the same thing. So yeah, in all this situation, it still is the same. So yeah, we do actually want it to return. So I don't know why. Okay, so this is problematic. So I want to just see what srsc is. So print srsc, just to see. Sorry, I just worked through it with you guys. So, and that was one thing I was scared about. Like, I was scared how things are gonna shape up to be. So yeah, probably just problematic. So 1 1 2 1 0 1 1. Oh, that means it is repeating itself somehow. So let's say it sees this one, it calls it a new color, and then, oh, I think I see the problem. It calls like the old issue back on it. Hold on just for a second, sorry. So yeah, so as you can see, it just, sorry guys for a distraction, but I think the reason why that's the problem with recursion, because now if it goes to the new one, it doesn't update the image in here. That's problematic. So we would have to, the only problem here is we have to, let me see, there's one other thing I can think about. Let's just fully copy them, but let's see what goes on in here. I doubt will change anything. That's why I didn't want to trust it that way. But sorry, let's see, let's run it and see what goes on. But I doubt that will fix it. Yeah, I think, yeah, that's not gonna fix it. So because they'll show a couple of paths, unless I really make sure I fix it in a different way, but that will not work. You're right. So what we can do is, yeah, we don't need to do it that way. So basically, as I said, we can probably keep a dictionary. So dictionary equals that, and then we can also put the dictionary in there, dictionary, and then the reason why I'll show you guys why I'm going to put the dictionary, why I put the dictionary there, because as I think I spoke on earlier, it makes sense better if we put stuff in the dictionary and not update anything yet. So if the image this equals pixels, then yeah, so then we can just store the coordinates in the dictionary. So we can call dictionary sr sc, and we can set it equal to 1. So now we'll make sure that means we've seen it. So the only time we stop again is if we can also, if it's not equal to pixel, or sr sc in dictionary. So if we see it's already in dictionary, it will return. It won't look through this, because one of these coordinates, C112101, it's gonna be in the dictionary. Like, these coordinates are gonna be there, so it will just stop automatically. So it won't loop through. So that way it works out. So it's just extra space and stuff, but I think that is definitely more efficient and it works better. So let's just see. So we can return image. No, okay, then that means that we can't just return the image right now, because all this one now the dictionary has just stored the coordinates. So now these coordinates that needs to be changed, we just have to go through them. So for I, in, let's say, dictionary.keys, now we have each of the keys, which are the coordinates, and so now we can do image I0, which is this, and then I1. So we can set it to be equal to the new color. So this is gonna work. This should work, unless there are probably a few things I have to fix, but aside that, that should work. So let's run it again and see what goes on. Oh, 6% arguments, but 7 was given. Oh yeah, it's not having a dictionary. So yeah, let's run this again and see. Sorry guys, I know I should have probably not perfect like other YouTubers, but I just go authentic with you guys. So let's use example test cases and run the code just to see what goes on. So all of them are perfect, so let's just see. Yeah, so let's just run a game for good luck, just to see, and then we can submit. Fingers crossed. Let's see, please don't give me RC. Perfect. Oh, memory. I thought I was even using way more memory by using a dictionary, but here we go. Voila. So once again, first time, no problems, accepted, and this is simple. So you see why I did not feel right about the first approach, because if you change it along the way, I mean, I could still probably, if I still wanted to use that approach, it would probably save more time and be faster rather than looping through all of this again. Because if all of this, imagine worst case scenario, all of this needs to be changed, you have to loop through the whole thing again. So that's bad as compared to like fixing it there and then. So it probably would have increased my own time, but I still think it doesn't really matter, because what really matters in the end is just making sure that you're really good. So I think you get working solution. This works. If we still had to really change things up, like to make whatever we did work, we have to find a way of making sure that whatever we're putting into our image here, or the images here, all keep getting updated. Like this image still needs to get updated, because whatever is going in this image here, it's fine. But when it comes back, this image guy here is not gonna have the same image here as this guy on the same recursion stack. This image guy is gonna have something different on the recursion stack. So it's just dangerous. It has to be updated through. So if you, yeah, that's the only danger with that. But that's another thing. Plus, yeah, color was same. New color should definitely be the same. They still be the same. Dictionary still be the same. But yeah, I think the only problem is, yeah, you might have to update the image array in some way, sort of. So But yeah, this is safe. This is a safe route. It works, and then perfect. So hey, thank you guys for watching, and then keep it under 20 minutes. Hey, you like it, give me a thumbs up. Let me know what questions to solve and everything. And hey, have a good one. Have a good weekend. Bye.